In section 1 of chapter 12, we're going to be talking about two ideas. Well, it's actually four concepts, but two of them you've had before. The two ideas are arc length and area of a sector. Now, arc length is actually a piece of the circumference of a circle. Just to remind you, circumference is the distance around a circle, and it's what we call perimeter in every other type of shape. But in a circle, that's actually called circumference. There are two commonly used formulas for circumference. There's circumference equals pi times diameter, and then there's the one that we'll use the most, and that's circumference is equal to 2 times pi times the radius. So let's take a look at a few example problems here. In this first example, it asks us to find the circumference, and it gives us the radius. And then it says leave the answer in terms of pi. Now that's going to become important. Because they gave us the radius, we'll use the formula circumference equals 2 times pi times the radius. And then we'll fill in the radius. Circumference equals 2 times pi times 9 centimeters. When we work that out, we won't put the pi into our calculator because it says leave in terms of pi. So 2 times 9 gives us 18 pi centimeters. And that's a piece of the perimeter. Let's try a second example. In this second example, they actually ask us to find the radius. And they give us the circumference. They tell us to round to the nearest hundredth. Since we're looking for the radius and we're given the circumference, we'll use the same formula we just used. Circumference equals 2 times pi times the radius. This time we don't know the radius, so we'll fill in the circumference, 26 inches for the C and 2 pi r on this side. To solve it, we'll divide both sides by 2 pi. When we do that, we'll end up with just the r left on the right side. And then on the left side, rounding to the nearest hundredth, which means 2 decimal places, we have 4.14 inches. Two problems using the same formula where we actually had to find different things. First one, we were finding circumference. Second one, we were finding the radius given the circumference. Now, in problem number 3, it asks us to find the distance traveled in 15 revolutions. And to find the distance traveled in 15 revolutions, we'll find the distance traveled in each revolution. And in each revolution, we'll travel one circumference. So we're going to first find the circumference. When we go to find the circumference this time, they did not give us the radius. But they were nice enough to tell us this total distance right here, from the top of the tire to the bottom. That's actually the diameter. So to get the diameter, we'll add all of those numbers together. 5.5 plus 15 plus another 5.5. The diameter then would be 26 inches. And since we have the diameter, we'll use the first formula for circumference. Circumference equals pi times diameter. So the circumference here would be pi times 26 inches. Now they've asked for it to the nearest inch, and they've asked for it also to the nearest foot. But this is just one circumference, so we're not ready to round yet. Each revolution we go 26 pi inches. So in 15 revolutions, we'll have to take 15 times 26 pi inches. And then we will round that. That comes out to be 1,225 inches. They also asked for it to the nearest foot. Well, to get our answer to the nearest foot, we just have to take that inch value 1,225 inches, and then we divide it by 12. So to the nearest foot, 102 feet. Okay, make sure that one makes sense to you. Feel free to pause if you need to. Number 4, example number 4, we are looking again for the circumference of a circle. They give you the diameter, and they do ask you to round to the nearest hundredth. Anytime you're given the diameter and asked to find circumference, the formula with the D is the one that's the most easily used. So the circumference will be pi times 5 inches. And we'll put that entire thing into our calculator, and we get 15.71 inches. Pretty straightforward problem. Number 5. Number 5 is asking us to find the radius. They give us the circumference. So we're going to use the circumference formula that has radius in it. Circumference equals 2 pi r. We're going to put the 17 pi feet in for the circumference equals 2 pi r. To solve it, we'll divide by 2 pi. When you do that, you can see that we just have the radius by itself. And the pi's will actually cancel, and we end up with 8.5 feet. Again, pretty straightforward once we put that in. Well, now we're going to talk about just a piece of the circumference. A piece of the circumference is called arc length. And arc length is different from arc measure. Arc measure was what we talked about in chapter 11. Arc measure was in degrees. Arc length is in linear units. And the arc length is the fraction of the circle times the circumference formula, 2 pi r. And the arc length is often denoted with just a capital L. Let's take a look at an arc length problem. So here we're asked to find the arc length. And we're asked to leave our answer in terms of pi. Now, in the chapter we just finished, we learned that the measure of an arc is equal to its central angle. So that would be 60 degrees. That means if I want the arc length from A to B, L, I take the fraction of the circle, which would be 60 degrees out of 360 degrees, times 2 times pi, and they gave us the radius. Since they asked us to leave it in terms of pi, we won't put the pi into our calculator, but putting everything else into the calculator would give us 8/3 pi, and the units would be centimeters. So for the arc length formula, we need to know the number of degrees for the arc, which is the arc measure, divided by 360 times 2 pi r. Let's try another one of these. So in this problem, we're asked to find again arc length. Once again, we'll need the measure in degrees of the arc. It's the same as the central angle. And then the arc length will be equal to the fraction of the circle, 120 degrees out of 360, times 2 times pi, times our radius. This one tells us to round. We're rounding to the nearest hundredth. So we'll put the entire thing into our calculator. And the arc length to the nearest hundredth comes out to be 23.04, and the units are centimeters. Sometimes they'll ask you for arc length in terms of pi. Sometimes they'll ask you to round it. So you have to pay very close attention to that. Number 8 is a slightly different type of problem. In number 8, they've asked us to find the circumference. And they've given us information about the arc. Whenever they give you information about the arc length, the part of the circle, and they ask you to find something about the full circle, you're going to use a proportion. You're going to use a proportion to compare the part of the circle to the whole circle. Let me show you how that's done. Keep in mind, we're going to be comparing the part to the whole. So to begin with, the number of degrees in the part is 40 degrees. The number of degrees in a full circle is 360 degrees. On the other side of the proportion, the length of the arc in the part is 4.19. And we're looking for the whole circumference of the circle. We now have it set up, so we're ready to go ahead and cross multiply. 40 times c, of course, gives us 40c. 360 times 4.19 gives us 1508.4. To finish it, we'll divide by 40 on both sides. And our circumference comes out to be 37.71 inches. So whenever you're given information about the arc itself and then asked to find the circumference of the circle, you're going to use a proportion. Let's take a look at another problem. In problem number 9, they're asking us for a measure of the arc. So they're asking us for the degrees. And they give us the arc length, and they give us the radius. So in our arc length formula, we know the L, 44 meters. We don't know the fraction of the circle, so we're going to put x over 360. Sorry about that. And then, of course, we know the 2 pi, and we know the r. Now, to solve this for the x, I would suggest we get rid of the 360. Whenever you have the number on the bottom, we'll multiply both sides by that. So we'll multiply both sides by 360. 360 times 44 gives us 15,840. And on the other side, we actually have 2 times pi times 15.28 times the x. In order to get the x by itself, we'll divide both sides by the 2 pi times 15.28. Now keep in mind when you put this into your calculator, you're going to want to put a grouping symbol around that whole bottom. And it asks us to round to the nearest hundredth. So we end up with x equals 164.99. That's the measure of arc RS, 164.99 degrees. Let's practice a problem. So here we're finding arc length. The arc length L is equal to the fraction of the circle, 75 degrees out of 360 degrees, times 2 times pi, but they didn't give us the radius. They gave us the diameter was 9. So the radius will be 9 divided by 2. the radius being 4.5. And the units are yards. This time it says round to the nearest hundredth, so we put the entire thing into our calculator. We come up with 5.89 yards. Let's try another one. Let's try one of those where we have to use a proportion. So they're asking us to find the circumference, and they give us information about the part. So we're going to use a proportion again. And we're going to compare the part to the whole. To begin with, the degrees in the part, 270. The degrees in the full circle, 360. The arc length on the part, 61.26 meters. We're looking for the entire circumference. We cross multiply. Of course, we have 270c. And then 360 times 61.26 gives us 22053.6. We divide by the 270 on both sides. We find that the circumference here, 81.67 meters, rounded to the nearest hundredth. Let's try one where we have to solve for the radius. So here we're solving for the radius. They give us the arc length, and they give us the degrees. So I think we can use the formula for arc length. The 10.5 will go in for the L. The 150 degrees over 360 for the fraction of the circle, and then 2 pi times r. And again, I encourage you to get rid of the fractions. So I'm going to recommend that we multiply by 360 here on both sides. 360 times 10.5 gives us 3780 equals. And on the other side, we have 150 times 2 pi times r. Again, to finish solving it, looks like we have to do some division. We'll divide by the 150 times 2 pi. And again, when you put it into your calculator, you'll want to enclose all of that in a parenthesis. On the right side, we can see that everything cancels except the r. And on the left side, to the nearest hundredth, we get 4.01 feet. Any questions on arc length? We have some practice problems for you to do then. And remember, I'm available during the help times from 2 to 4 each school day. Good luck with this first section.